Yes. Right. Mass moment of inertia. I've uploaded the question. So we're going to do this question. Okay. Can you check? Do you all have this on Avenue to Learn or not? Can you check, please? Yes or no? If it's not there, I'll upload again. Is it there? Is there? Oh, thank you. Oh, it is. Thank God. Okay. Example. So this is the final example, and it's not that bad. Okay, mass moment of inertia. It's not that bad. Okay. The pendulum consists of two slender rods. Okay, they highlight it consists of two slender rods. And one is AB and the other one is OC, which has a mass of 3 kilograms per meter. The thin plate, they highlight this as a what? A thin plate. Okay, has a mass of 12 kilograms per meter squared. Determine the moment of inertia of the pendulum about an axis perpendicular to the page. I think I copied the wrong question. Okay, everything is still the same. Get rid of this. Okay, so we want to determine my bad. We would like to determine location y bar, okay, which is the center of mass, okay, G of the pendulum. Later on, I'll tell you what is so important about the center of mass. Okay. Then after that, we are going to calculate the mass moment of inertia about point G, which is the mass moment of inertia. The formula that we're going to use, okay, are the parallel axis theorem, which states that I is equal to Ig plus by md squared. Okay, so I did write this formula last week, and the formula for y bar is equal to summation of m y bar divided by mass. Okay, I will change this to capital Y. Okay, and I'll change this to capital Y also. Okay, so that's what we are trying to locate. So we're going to label our section. Okay, we're going to label our section. So we call this H rod. H dictate that this is a horizontal rod. Over here is V rod. Okay. Now, if we were to look at the table, right? Which one are we going to use, right? So let me see, can I copy this table? Hold on. I can copy this table, but I want to do something. Hold on, give me a minute. I'm still so pissed off that you all can't do those questions. I'm sorry. Well, yes. No. Yeah, let's see what happened. Okay. Yeah, I'm sorry. Should not have done that. But I was so like hopeful. No, I was so hoping to see you guys like breeze to those questions, and I'm like, yes, you got the concept. I'm like, I was at work to 2 o'clock looking at most of how you answer it. I'm like, Eugene. If the question was straight from the homework, will y'all have done better? So when you study, you don't look at my lectures at all. You just go straight to the homework. Okay. It's okay. I'm sorry. I should not. Okay. Now, sorry. Come back. Focus. Okay, focus. I'm trying to focus down here. Okay, I'm really trying very hard. So down here, the dilemma is this. This, do you classify it as a thin ring, or are you going to classify as a thin circular disc? What are you going to classify it as? Okay. So if you are not sure, read the question. I was not sure the first time I'm doing. Yes. Yes, we could. So if you look at the question, it says that it's a thin plate. Okay. And you are given what? You are given radiuses. So this, the outside, I'm going to call it the solid disc. And over here, we are going to call it a hollow disc. Are we clear? Okay, our solid disc and a hollow disc. Okay, why we can't use thin ring? Because we have information regarding the two what? Radiuses. Are we clear? Okay, so don't just okay. So to do this properly, you usually form a table. Okay, you usually form a table. So we are going to apply this formula over here. So you have section. So section, you have H rod. You have your vertical rod. You got your solid disc. And you have your hollow disc. Okay. So let me bring the image clearer to you guys. Okay. So with all the geometries, so on and so forth, we know how this thing has been classified. So we look at we are going to determine the mass first. So we know that for the slender rod is 3 kilograms per meter, right, given to us. So the horizontal rod, it will be 3 multiplied by a length of 0.8. Okay, so 3 multiplied by 0.8 is equal to 2.4 kilograms. And the vertical rod is 3 multiplied by 1.5. 4.5 kilogram. Can you put a summation at the end of down here also? Now, when you are doing this, have Dr. Koshi taught you how to look for bending moment, stress induced by bending moment? Yeah. Yes or no? Where my over I, have you seen that formula yet? No, it's okay. The approach is the same, only this is mass. Now, the solid disk is, if you look at the mass of the solid disk, it's 12 kilogram meter squared. Okay, so we have 12 multiplied by pi r squared. I feel like getting you to rewrite term test 2 and everything come from the homework. But I don't think that's a good idea. Yeah. Yeah, let me wait for the grades to come out, okay?
May not be too bad. May not be that bad.
12 times by shift pi, okay, and that is 0.377. Maybe I will start giving money to my TAs. So now, that is follow this, okay? And there's a minus sign down here because hollow. So when you do the summation of everything, you have 2.4 plus 4.5 plus 3.393 minus 0.377. You get 9.916 kilogram. Okay. So the next thing that we're going to do now is we are going to compute Y bar from the top. Y bar from the top, what it means now is we are going to take the datum from the top. Okay, so this is our datum. You can take it from the top, you can take it from the bottom, it's going to be the same. Okay. So the Y bar distance for rod AB or the horizontal rod is going to be equal to 0. The vertical rod will be equal to 1.5 divided by 2. Okay, so 1.5 divided by 2 is equal to 0.75. And then the solid disk, either the hollow or the solid disk, the distance is equal to what? 1.5 plus by 0.3. So this is 1.8. Likewise, over here, this is 1.5 plus by 0.3. So what is going on down here? Why the top rod is equal, the horizontal rod is equal to 0? Because this is the what? This is the individual Y bar, small Y bar. And at the datum is the same. Between O and C, this is the what? Between O and C, this is our what? Y bar. So the distance from here to here is equal to what? 0.75. And at this distance over here, the distance from here to here is equal to what? Is equal to 1.8. Okay. So from here, we do mass multiplied by Y bar at the top. Okay. So 2.5 times 0 is equal to 0. 4.5 times by 0.75 is equal to 3.375. 3.393 times by 1.8, 6.1074, or 107. 0.377 times by 1.8 is minus 0.679. So then you do summation every time again. Now, why is it minus? Because what we are doing is we are going to remove the what? The hollow. Yes, sir.
The datum from the center of the order.
Yes.
Because just because
we are not given the thickness at all.
because the radius.
Yeah, yeah.
Just take the top. Right?
Yep, yep. Okay. The question asked is why I take it from the center, because this dimension we don't know. Okay. I realized that because I got review, you know, those prof review the course say that when people ask questions from the front, behind got not a clue what is happening, right? And you guys knew about it, did not tell me about it, just whatever, cheeky thought. Okay. But anyway, I'm feeling a bit better now, okay? So don't worry. So it's got 8.803. So what we see over here, this is kilogram meter, okay? So therefore, the big Y bar is equal to 8.803 divided by 9.916. Okay, so 8.803 divided by 9.916. This is equal to 0.888. Oh, it's a very good Chinese number. We love this number. 888 means prosperous for everybody. Okay, so it's 0.888 meters. Now, what does this distance mean? Anyone, what does the center of gravity means? Knowing that it's a center of gravity and knowing what it means are two different things. Any idea? Anyone? Yes. Say it again. Yeah. It's absolutely right. Okay. So this is a really simple example. This is my ruler. Left and right is 30 centimeter. I put my finger down here.
Wow.
The left. Oh, seriously? The left is equal to its right. At this point over here is exactly where it's at. Is what? Center of gravity. Now, why is the center of gravity so important? Whatever forces, external forces, listen to me, okay? Whatever external